Welcome to today's video tutorial. Today we're going to be talking about some work that we did recently where we refactored Nginx to be multi-threaded versus multi-process. So a lot of people know that we've had Nginx running for years now, although it was locked down to a single worker process. And that's not typically how one would deploy it in prod. Typically, you have this concept of the front end servers, and so these are the app workers that are actually exposed to the internet, and then you have the back end workers, and then that might be PHP, it might be Ruby, Python, whatever it is, and so it just kind of shuttles the front end to the back end, the traffic. So what's the problem, right? Well, the problem is that unikernels are single process by nature. And so to actually kind of get all the performance that Nginx gives us, we did go in and make some patches. And I'm going to walk you through the patches and walk you through some of the other code, and we'll do that. So we wrote this article. Basically, if you like reading versus watching videos, I'm going to say basically the same thing. But let's go ahead and get into it. So Nginx, comes out in like what a pretty long time, like 2004. And so that's interesting because in 2004 we just got Linux 2.6, which had MPTL threads. That basically gave us the primitives to actually use good threads in Linux, threads that give us performance. There was thread implementations before, but they were kind of crap. And then also with the Intel processor, the Northwood processor, we were able to get multi-core processors with SMP. And so those two things around 2004 basically allowed us to actually use multi-threading for performance reasons. But that's also kind of like when Nginx first came out, so it didn't really use it. It's been around for about 20 years, and so that's why. So what's the work to do? Well, it actually wasn't too much work, and I'll go ahead and switch over to the code. So the first thing that we wanted to do, if we're looking on the left side, these are two patches that we created. The first patch, as you can see, we got rid of some signaling. And so typically in like a multi-process setup, you'll have a master process, and then it kind of forks off some children, and then they communicate via IPC and signaling and this sort of stuff. Anyways, this communication we didn't need anymore, so we just nuked it, right? Now, if we go to the right pane here, we have a little bit more work. And so, essentially what we did was the worker processes that's in the config file, we went ahead and substituted that. Basically, it's worker threads now, right? But we left the name there. And so the main work that we were able to do here was to go through and deal with global and static variables. So especially in a C code base, but pretty much everywhere, globals and file static variables are actually pretty problematic when you want to convert to threads, mainly because these variables are going to be copied in a multi-process world from process to process, right? But if you're in the same process because you changed it into threads, now you have issues because these can change. So what do you do? Well, what you can do is use this underscore thread keyword right here. And so if you apply this basically everywhere where you see a global or a static, you can basically keep automatically tell the compiler, hey, make a copy of this for each thread. And that way you're cheating essentially, and you don't really have to deal with like mutexes or any other synchronization. In many cases, you can just apply this and you'll have a thread local storage, basically a copy per thread that you can use. So that's one change that we did. And then also Nginx had this Nginx channel where it basically pass around file descriptors. Again, we didn't need that because we didn't have the master to worker child relationships and the communication, so we nuked that. We got rid of the UID and group ID code, which the calls for that were set UID and set GID. So we stub these out anyways. If you look at the implementation in Nanos, it's just stubbed out because we don't do users. There's no interactivity in Nanos, and there's no ability to like run other programs. It's really just kind of like the equivalent of one user. And so there's never really a method where you would actually change to a different user. And so that's why they don't exist. And then, we got rid of these as well because there was also static variables inside of glibc. So this is kind of another issue is a lot of this code was kind of just written in a time period where we didn't have SMP, we didn't have good threads, we didn't have all this stuff. And so and that's part of the wider story for unikernels. It's not just, I want to run my Go app as a unikernel, or I want to run my Rust app as a unikernel. There's just all this software out there that needs to be upgraded. It's like Nginx. I'm not picking on Nginx, but it's 20 years old, right? It's literally older than some of you people that are watching the show. That should tell you something. We kind of did the same kind of breakdown with Postgres a month ago, if you rewind past one or two videos, and we kind of go into it. Anyways, so these are the patches. This is actually not a ton of code. It looks like a ton of code, but it really isn't. As you can see here, we have 300 deletes, 80 inserts. Not so much, right? Okay, so let's go over to the actual Nginx program. So as I mentioned before, you can tell that we actually have a handful of Nginx packages, right? So, and I've been cutting them for various purposes throughout, the years. We started off with this normal 1.15, and then I cut a couple of these Nginx PHP, Nginx Ruby, and Nginx Python. Basically, they embed the interpreters inside of Nginx, which is kind of cool. Because we don't do CGI. I mean, you can do that over TCP, but you're not going to do it otherwise. And then you can see here we also cut some packages that supported Quick and HTTP3. So this is a way for things to speed up, especially for mobile phones. They will make a lot of use for this. And if you pay attention to Meta or Google, when they're talking about their advertising, they'll tell you that mobile traffic is totally dominant. And you can see that, right? You're on the subway, you're at a restaurant or whatever, people are on their phones. It's just what it is. So that works really great. Now you can see this Nginx-MT stands for multi-thread, obviously. Basically, we cut a package. It has these patches that I showed you in it. And then we also kind of change things out. So let me just show you the config real quick to see what else besides the packages. So we got Nginx 1.18. And so where I'm doing this ls and tree on a package, basically the unzip package is the actual tree layout of the file system. Anything that you stick in the sysroot, essentially. And you can see here for this package, we have etc nginx, and we have nginx conf. I'm just going to cat that out so you can see. And so you can see the very first line, we got worker process 1, right? So it's automatically locked down to just one process. And that works actually pretty well for a lot of things, but more people are probably used to bumping that up to 4 or 8 or however many threads that they have available. So that's what the old stuff used. Now let's look at the new stuff. So ops, packages, iberg. Now we'll go to MT, back to sysroot. User local. This one got stuffed into user local. No rhyme or reason. This is part of the packaging process. You just kind of, you know, do whatever you think is best. All right, so this one's here. We'll go ahead and cut that, and let me just go ahead and clear the screen. All right, so now you can see we bumped it up to 2, right? And so generally what you want this worker process is, in our case, it's actually worker threads, right? You want that to be matching the number of threads that you have. So if you deploy to like a, EC2 small or micro, you have like 1 thread, right? But maybe you deploy to a medium and you get 2 or 4 threads. So whatever it is, you want to match that. So in this case, I wouldn't do 2 on a micro instance because I only have 1 thread to begin with, right? And I forget, but a micro might even be shared, meaning some other users is sharing that thread with you. For security purposes, if you got something sensitive, you might not want to do that. It's generally okay in most cases, though. I wouldn't freak out about it. But yeah, you still wouldn't want to put 2 on there because you're not going to get any more performance out of it. So in this case, we stuff that in there. All right. So, and then, this also listens on 8083 and we have TLS on 8084. These packages are demo packages. I would encourage you just to fork this package, create your own, upload it to the package repo, customize it to your heart's content. You can use private packaging if you want. And that way, if it's something sensitive, nobody can see it. But yeah, these are just demo packages, right? All right, so let's go ahead and show you how this works. So we'll do ops load ivory nginx mt, then we'll do 125.2. Let's go ahead and listen on both just so we can kind of see stuff working. Oh, you know what? I'm running an old Nanos version, so I'm going to grab the nightly just by doing this -n. That's what that error was complaining about. I don't keep all of my stuff upgraded. This is another error saying my TFS is old, but it's backwards compatible. So this is just a machine that hasn't been upgraded with the latest stuff. Anyway, so we go into the other window. We can pull out curl and go for 8083, like it says forbidden. Okay, well, we can do HTTPS, do 8084. This was a self-sign cert, so it says, hey, features unikernels. All right, let's go ahead and do, let's pull out AB. AB is not the best for benchmarking. I would use maybe work instead, but this is for demo purposes. It's pretty good. So let me just do this. All right, so we got that. Great. We'll bump it up to 100. Okay, so we got that. All right, now if you wanted to try out threads locally versus deploying to Google or Amazon, what we're gonna do is, I believe it's -SMP2. Okay, so now we say, hey, I want to give 2 threads to this instance, and we can kind of confirm that real quick. Let's clear the screen. PSOX. So now we just want to look for SMP. Should say, maybe you guys are seeing it before me. Here we go, SMP2. And so basically it says instead of 1 thread, it's getting 2 threads. Now we can kind of try it again. I always do this one for a test, and then I do another for that. And so now it's gonna bounce between 2 of them, right? And you can just kind of crank it up. This might stall, but yeah. So now we just kind of did what is that? Is that like 20,000 requests a second? So you wouldn't be able to do that with the 1 thread if you're using the old package, right? And so that kind of demonstrates the the power of multi-threading. Why is multi-threading faster than multi-processing? It's a good question. A lot of people don't understand this. They're never taught this, right? But essentially, when you switch from process to process, you have to do what's called a context switch, and so there's different context switches depending upon the context. Not to get super confusing, but you could have like a K thread to K thread switch. You could have a kernel thread to user thread switch. You could have a user to user thread within the same process, or you could have a process to process. And so that process to process is actually incredibly expensive. And work was done recently to kind of like lower the cost of that in the past so many years. And then Google kind of dug into it more, and they're like, you know what? It's not just the process to process context switching that's kind of slow, but it's also the scheduling of these processes. So I'm on a Linux box right now, right? You can tell that, so we do, I'm on Ubuntu Jammy right now. So, without me installing anything, there's hundreds of processes on this. And this is like a decent box because it's sitting, next to my legs, right? It's not a virtual machine, but, I still don't have like hundreds of threads on it, right? So some of these things are not going to be running at the same time. They have to switch out. They have to timeshare. And so, the process to process switch is pretty hefty. With threads, since the memory is shared, heaps are shared, for instance, in threads, it just runs a lot faster, right? When you're dealing with larger data sets and you decide you want to fork a process, that's also super expensive. But yeah, that's essentially what the deal is. This has kind of been a whirlwind tour of the Nginx multi-threaded work, and as I mentioned before, we made a fork of Postgres, we made a fork of Nginx. You'll see more work like this from us in the future as we do more of the work that we think is necessary to upgrade the software infrastructure out there, because a lot of it's just like super old and stuck like decades in the past. All right, this has kind of been a long one. Catch you later. Bye.